Welcome everyone to another video for pre-calculus. In this video, we are going to discuss about real zeros of polynomials. So the first thing that we are going to look at is the rational zero theorem, which states that if we have a polynomial here, then um, the rational zeros of the polynomial can be written in the form p over q. Okay, so it can be written in the form p over q, where p and q are integers, and p is the factor of a naught or the constant term, and q is the factor of the leading coefficient. Let's look at an example how to apply this. Okay, so here we have a polynomial. So we are interested in finding the zeros of this polynomial, or we are interested in writing this in factored form. So the first thing is we need to find what are p's and q's. Okay, so we'll first find p. So p represents the factors of the constant term. So here the constant term is 4. So that means we are going to find the factors of 4, and then we write both positive and negative factors. So factors of 4 are positive and negative 1, positive negative 2, and then positive negative 4. Similarly, we'll write q. Okay, so q represents the factor of the leading coefficient. So the factors of 2 are positive negative 1 and then positive negative 2. Now, all the rational zeros for this polynomial is given by p over q. Okay, so that means p over q means we'll divide p by q. So if we take the first p that we have here, positive negative 1, and if we divide by positive negative 1, we just get positive negative 1. And then if we divide 1 by 2, we get positive or negative 1 half. And then we'll take the second one, divide by 1, we get positive or negative 2. And if we divide 2 by 2, we get 1. We already have that factor, so we're not going to repeat it. Then we'll move on to the third one. So 4 divided by 1 is 4, so positive negative 4. And then 4 divided by 2 is 2. We already have 2 here. So all the possible rational zeros for this polynomial are within this list of numbers. So we have 8 numbers here. So the rational zeros are within these 8 numbers. Okay. So now first we need to at least find one rational zero, and then after that we can just use the synthetic division, and then we can factor this polynomial and we can find the rest of the zeros. So for that we can just plug it in and check. So we have 1 and negative 1. So if we plug 1 in here and see if we get a 0. Okay, so that's how we are going to test. So if we take 1 and plug it in here, so we get 2 times 1 cubed plus 7 times 1 squared plus 4 times 1 minus 4. And that's not going to give us 0. So I don't think 1 is a 0 for that polynomial. So we'll try with negative 1. So 2 times negative 1 cubed plus 7 times negative 1 squared plus 4 times negative 1 minus 4. And that gives us negative 2 plus 7 minus 4 minus 4. And this one is also not going to give us 0. So both positive and negative 1 are not the zeros. Then we'll try with negative 2 now. So 2 times negative 2 cubed plus 7 times negative 2 squared plus 4 times negative 2 minus 4. And then let's see, negative 2 cubed is negative 8 times 2 is negative 16. This is 28. And then we have negative 8 and then minus 4. So that means 28, and this is also 28, so it's 0. So that means negative 2 is the 0 of that polynomial. So we know one of the zeros. So what we are going to do next is we are going to divide the polynomial by negative 2 in order to get the other factors. Okay, so we know negative 2 is the 0. So we are going to divide that polynomial by negative 2. Okay, so we'll do the synthetic division. So we have 2, 7, 4, negative 4, and then we'll draw this line right here, drop down 2. 2 times negative 2 is negative 4. When we add them, we get 3. 3 times negative 2 is negative 6. When we add them, we get negative 2. Negative 2 times negative 2 is positive 4, and 0. So this verifies that negative 2 is the 0 of the polynomial because we got the remainder as 0. Now what we are going to write is, instead of writing this polynomial, we are going to write f of x equals, the first factor is, the 0 is negative 2, so that means the factor is x plus 2. And the second factor is right here, which is 2x squared plus 3x minus 2. Now what we do is we'll go ahead and factor this quadratic term here, and then it will be completely factored. Okay, so f of x equals, so we have x plus 2. Now the factors of this quadratic term, you can go ahead and factor that. So we'll get x plus 2 times 2x minus 1. So this is the polynomial in completely factored form. Now if you have to find the 0, then from here we get x equals negative 2. From here we get again x equals negative 2. That means it's the same 0, so the multiplicity is 2. And then from here we get x equals 1/2. So the zeros are negative 2 and 1/2. So that's how we use the rational zeros theorem to find the zeros of a polynomial. So the next rule that we are going to look here is the Descartes' rule of signs. What this does is, this really does not help us to find the zeros, but what it tells us is, it tells us how many possible positive and negative zeros we have for the given polynomial. Okay, so the rule here is, we'll look at the variation in sign. Variation in sign means we'll first put the polynomial in ascending or descending order of their power, and then we'll see if the sign is changing from one term to another. So if we have a positive term and then the next term is negative, then the sign changes. That is one variation. If the sign does not change, does not go from positive to negative, then there is no variation. Okay, so if the variation of the sign, whatever the number of variations we have, so the positive zeros, the number of positive zeros are either the number of variation, or we'll count down by 2. Okay, we'll count. So for example, if we have three variations, then we count down by 2. So 3 or 1. If we have 5 variations, then we say 5, 3, or 1. If we have 6 variations, we say 6, 4, 2, or 0. So we'll count down by 2. Okay, so that many possible positive zeros we'll have. Now for the negative zeros, we do exactly the same thing, but what we are going to do is we are going to rewrite the polynomial function by substituting x with negative x, and just we count the variation in sign. So let's look at an example, and it makes more sense when we look at the example. Okay, so first we have a polynomial f of x equals 2x to the fifth minus 5x squared minus 3x plus 6. Now let's go ahead and count the variation. So we have, this is in the exponents are in descending order. So we have the highest power, then second highest power, and then so on. So this is good. If it's not in order, we need to make sure that it's in order. Now what we are going to do is we are going to count the variation in the sign. So this is positive here, and this is negative. So when we go from here to here, the sign changes. So we have one variation here. When we go from negative to negative, the sign does not change. So there is no variation here. Now when we go from this term to this term, the sign changes from negative to positive. There is another variation. That means we have two variations here. So the number of, so possible number of, okay, so the possible number of, the possible number of positive zeros. Positive zeros are So two variations, so it's either 2 or we count down by 2, so 0. So there are, it means for this polynomial function, there could be two positive zeros or no positive zeros. Okay, that's what this says. Now, the next thing is we are going to look at the negative zero. So for the negative zero, what we need to do is we need to find f of negative x. Okay, so when I substitute x with negative x, I get 2 times negative x to the fifth minus 5 times negative x squared minus 3 times negative x plus 6. And then we get f of negative x equals negative 2x to the fifth minus 5x squared plus 3x plus 6. Now we'll go ahead and count the variation again. So we go from negative to negative, there is no variation. When we go from negative to positive, so there's one variation. Then we have positive to positive, there is no variation. So that means we have only one variation of sign. So the possible number of negative zeros are 1. Then if we count down by 2, then we'll get to the negative. So it's just 1. So that this function will have at least one negative 0. Okay, so that's what this Descartes rule tells us. That's all for this video. I'll see you again in the next video.